Hey everyone, good morning. I am Priyanshi Agrawal and welcome back to my YouTube channel. Now we are going to see today's Leetcode daily challenge, which is find minimum time to reach last room second. So before watching this video, I would highly recommend to go and watch this video, which was find minimum time to reach last room first, which was the yesterday's daily challenge. And these both questions are completely similar, I would say that, with just a minimal minute difference. So I have explained everything in this video, from the intuition to the approach, why not greedy by Dijkstra. I have explained everything in this video, which I am not going to cover in this video. So please go and watch this video first and then come to watch this video. Okay, so let's see what is this question and what's the difference between both of these questions. So in this question also there is a dungeon with n cross m rooms arranged as a grid, and you are given a 2D array move time of size n cross m, where move time of ij represents the minimum time in seconds where you can start moving to that room. You start from room 0, 0 at time t equals to 0 and can move to an adjacent room. Moving between adjacent rooms take 1 second for one move and 2 seconds for the next, alternating between the two. Return the minimum time to reach the room n-1, m-1. Two rooms are adjacent if they share a common wall, either horizontally or vertically. So in yesterday's question also, all the information was same excepting this one. Moving between two adjacent rooms takes 1 second for one move and 2 seconds for the next one. In yesterday's question, moving between two adjacent rooms takes 1 second for every move. But in today's question, it takes 1 second for one move and then 2 seconds for the another move, and then again 1 second for another move, and then again 2 seconds for another move. But in yesterday's question, it was 1 for all the moves. It's just the difference of this thing in both of these questions. So that's why I would highly recommend, please go and watch this video to get the intuition about this question, to get the approach of this question. Because in this video I am going to cover mainly this difference between these two questions. Okay, now let's see what does this means and how it will affect our answers. Okay, so let's try taking this example. Let's see. So in which we have this 2n cross m grid, which is filled with zeros. Cool. Which is filled with zeros. Okay. Now what we can do? We need to start moving from 0, 0 and need to reach n-1, n-1, and we need to return the minimum time to reach the room n-1, m-1. Okay. So let's say at t is equals to 0, you start moving to the next room. Can we move to the next room? Yeah, because it's 0 and we are also at 0, so we can move to the next room. Okay, so at t equals to 1, we will move to this room because it will take 1 second to reach to the next room. Okay, now can we move to this room? Yes, we are at t equals to 1, which is greater than or equals to this value, so we can move to this room. Okay, now in the former move it took 1 second, so in this move it will take 2 seconds to reach that room. Okay, now can we start moving to this room? Yes, because 3 is greater than or equals to 0. Now in the former move it takes 2 seconds, so now again it will take 1 second. So now at t equals to 4 we will reach here. Okay, now can we start moving to this room? Yes. So in this move it will again take 2 seconds. So at t is equals to 6, we will finally reach the n-1, m-1 cell. So this is the minimum time needed to reach the cell n-1, m-1 from 0, 0. So I hope you get the difference between both of these questions. Like in yesterday's question, these all time values are 1 because it takes only 1 second to move from one cell to another cell. But in today's question, it takes 1 second for one move, then 2 seconds, then 1 second, then again 2 seconds. It means alternating. Okay. Now let's see the yesterday's code first. So in the yesterday's code, what we were doing, we were applying the Dijkstra algorithm, right? Why not greedy? I have explained everything. I have covered everything in that video. So please go and watch this video. Okay. So what we need to do in today's one? So we need to cover the point that what time it took for the former move, either 1 second or 2 seconds. We need to keep the track of that time. Okay, so here we are keeping the track of the time needed to reach for that cell and the cell which we are reaching, right? So with this only we need to keep the track of the time which was used, either 1 second or 2 seconds to reach that node. Okay, but we have is already created this int pair of int comma pair of int comma int. So adding something in this will make it too much complicated. So either we can create a struct node. What it will become? It will be int time, which is this time which we are storing, int alternating time, let's say, which will be this, either 1 or 2 seconds. Okay, and int I and int j, right? And then we can use this struct node here in the priority queue to define all of these values, the time needed to reach I and j, and the alternating time. It means either it took 1 or 2 seconds for the former move, so that we can decide the time needed for the next move. Cool. So this is the basic main difference between both of these questions. Okay, so in alternating time, let's say if we will create it as a bool, so 0 will tell you that you are adding 1, 1 will tell you that you are adding 2. Okay, so let's see the updated code with these differences. So here we have created a struct node, and we have also override this operator greater than, because here it is using it. So here we have created a struct node which have in time bool state I and j. State will tell you either 0 or 1. 0 will tell you that we are adding 1. 1 will tell you that we are adding 2. Okay, so in this priority queue we have used this node, and all other logic remains same. We have got this node here, and then got all other values like time, I and j, and the state, which I am referring to as alternating time. And another difference is, earlier we were just adding move time plus 1. Earlier we were just adding plus 1 in this. But now we are also adding alternating time. So what I have told you, that 0 means 1, 1 means 2. Okay. So alternating time can have these two values, right? So if the value of alternating time is 0, then we are already adding 1. So 1 will get added. And if the value of alternating time is 1, then we are already adding 1, and alternating time is also 1. So 1 plus 1 will become 2, right? I hope you get this thing. And by pushing in the queue, we will push the negation of alternating time. It means if it was 0, then we will push 1. If it was 1, then we will push 0. So that's the main difference between both of these questions. This was just the very basic difference in these questions, but if you want to know the approach of this question, intuition of this question, why we can't use greedy, why we are using Dijkstra in this, so please go and watch this video. I have explained everything in detail in this video. So now let's also talk about the time and space complexity of this question, which is also going to remain same. So as we are iterating on all the cells of the grid, and there are total n cross m cells, and we are using Dijkstra algorithm, it means it is using priority queue. Insertion and deletion in the priority queue takes log of n complexity, so it will take the log of n into m. And its space complexity is also going to be n into m due to priority queue, which can store up to maximum of n cross m nodes. So yeah, this was all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.